In the last video on file objects and reading and writing to files, I talked a lot about being careful to specify the directory location of your files in your script. I do so because it's a common source of errors or exceptions in codes. Specifically, it's a source of runtime errors. So the three types of errors are syntax errors, kind of when you misspell something, kind of type in something wrong and the code just doesn't know what to do. Um, the third type of error is a semantic error. That's when your script can run without any kind of hiccups or complications, but because of a mistake, the output that is produced or the process that went on was not the one that you wanted or that you would expect. Now, runtime errors are or they occur when the script can run, so it doesn't see any typos or anything that it doesn't recognize. But before it gets to an output, encounters some problem where it cannot proceed any further. And so you see these kind of exceptions, these traceback errors, and it can give you the line in which the error occurred, where it doesn't know how to proceed. So in this video, I'm just going to cover a structure that we can use in our code to anticipate some of these runtime errors and to handle them in a different way. So not getting a generic error message pop up. So some runtime errors include dividing integers by zero, so that's an undefined sum, or what is it, quotient there, undefined fraction. And there's nothing wrong with how it's typed out. So it wouldn't be a syntax error. Python attempts to calculate this, but can't. So it throws a zero division error. If you have a variable lowercase a and you're assigning it an empty list, if you then immediately try to reference the number 5 index item in that list, you'd get an index error, so it's not in the range. It doesn't exist in that sequence. But if B is an empty dictionary and you try to see what's the value associated with the key what, the string what, going to be a key error for that. And so if you try to create a file object, open up a file that doesn't exist in read mode, assign it to the variable f, you could get an IO error, input-output error. No such file or directory. So exceptions, kind of red text that pops up in the console, they're helpful in that they can tell you that the Python has encountered a runtime error and that the script did not finish executing, but they terminate the execution of the script and don't allow for anything further to happen. So in order to just not, I mean, ideally you can prevent these errors, but sometimes when you need user input and that's not yourself, they can be anticipated and dealt with in a simpler way, easy way. So one of the formats, or the structures in code to deal with it is the try except structure. So here we have the word try, T-R-Y with a colon, and then on the lower lines, one tab indented, the block of code, the statements that are going to be attempted, there's going to be executed first. Now, if that all goes well and there's no runtime error, so this file name does exist, then this except block is going to be skipped. So it'll just proceed to whatever was below that in a program. Now, if there is an error, though, a specific course of kind of response can be indicated. So here, except if there's an input-output error, so that file name doesn't exist, then specifically this string will get printed out. There is no file named space, and then the file name, whatever was input by the user. So this block of code is only going to be executed if there's a runtime error associated with executing the try code. Raise, this is a token that you can use to report an exception. So here there's a function defined called input number. X equals input, pick a number. So it's kind of a user input. If X is equal to 17, so we got the double equals because it's a Boolean operator. If that condition is true, raise a value error. 17 is a bad number. I don't know why 17 is a bad number here. Maybe if you were, I don't know, programming some sort of like a blackjack simulator, you could change that to 22 or lower numbers if you wanted to know whether or not to hit or not. And putting the pieces together here, so we've got a problem. So a text file contains donors' IDs and the amount donated in a comma-separated value file. Get the file name, read the data into a dictionary, output the donors' IDs in a left-aligned format, so they're all vertically aligned to the left, and the amount donated right-aligned. Well, actually, in this example, they're centered here. So here's the data file. It looks a little bit like the one with the school IDs in the homework assignment, and then the amount that they donated. So here's kind of a sample script response over 2 slides. So you import string module, sys. The first function that's defined here is exists. So here within that function, there's a try and accept format, exists with a parameter file name. So what's going to be attempted is simply opening that file as a file object, closing it, and if that's possible, returning true. If there is an input-output error, so if there's a problem essentially with opening the file, really the only thing that can go wrong here, return false. There's another function here, read in the text file. A function here, string to dict. Everything that's going to be read from the text file is going to be in the string format. And then finally, that's going to get printed out. And here is Python 2 format with a percent symbol for how to do that left aligned, right aligned. So the file name variable is going to be input by the user. So if conditional execution, if that file that was input exists, my stir, that variable, is going to be the output of the read-in text file using the file name. My dict is going to be string to dictionary, so it's going to kind of it's going to transform, convert the information to a dictionary from my stir, and then it's going to get printed. Else, so if it doesn't exist, it's going to print the file, and then the specific name does not exist. So we'll go back and see what these functions do. So read in text file, this is within the conditional execution, so only if that file exists. It's going to be opened in read mode. All of its contents are going to be read as a variable called str, which is going to be a string in format, just because that's the output of read. Other methods, like the read lines, could give you a list, but read gives you a string. That's going to be returned. And going down one slide, it's going to be input into the string str to dict function. So right here, list equals string dot split, and there's the input string, and you're going to split it at every comma, just because that's the format used here. A variable called dict is originally assigned to be an empty dictionary, and a variable called I is going to be used so that we can structure it as a while loop. So while I is less than the length of the list, so it's going to run through every different item in here, the 1, the 32.5, the 2, the 42.3, and so on, if I, that is to say the index location, is divisible by 2, if it's even. So this condition is asking if I is even, and if that's true, then key is going to be assigned that item. So the I index item of a list, which is the output of this string. Else, essentially, if this I is going to be odd, it's going to be a value. Val equals list I. So, there we go. So it's the same thing being assigned in either case. It'll be a different value specifically. Basically, all the keys, if we go back, will be the 1, the 2, the 3, the 4, because this is the index 0 item of the list. This will be index 2, index 4, index 6. Those will all be key, one at a time, and val would be the amounts donated, so the 32.5, and then later it would become 42.3, 89.9, and then after a key has been updated and a val has been updated, this empty dictionary will be filled in. So it's going to be an integer converted key and then float converted value. Because if they're the output of string, it's going to be a list, but the items will be strings. And then I is incremented until it runs through all of the comma separated values. And that gets returned. And then that's going to be my dict. It will be the argument passed to print dict function, which has a for loop for key comma value in dict input dot items. So this outputs a list of 2 item tuples, the key and the value. I'm going to print them out in an arranged format. So this first percent mark within the string corresponds to the 0 index item of that tuple, where the second corresponds to the value. D is anticipating an integer. The F is anticipating a float. The 0.2 has to do with the precision. So for some of these, actually for all of the decimals, they'd have an extra 0 when they get printed out, just because it's a 0.2. If it was a 0.1, we would see it as they're originally entered. So the -5 mentions the trailing spaces, the 8, the leading spaces. And so that's what we get here. So essentially, you can take this script and use it to, you'd modify it a little bit because there are 2 years worth of values. But this is a very good kind of starting point for you to modify and get an answer to the lab. And honestly, you don't need to structure it. Oh yeah, there we go. You don't even need to structure it with a conditional execution. You don't need to maintain this try except format structure. It's good to know about, But in terms of the bare bones, this is how you would read. You'd need to convert the string that is read from the file into numerical values, and then you'll need to format its output. Now, the tricky part would get to be where you need to pull out and somehow record both the 2019 totals and the 2018. And so you might need to kind of duplicate, have two different read objects. The number of students or the value would change from year to year, but the schools themselves would be the same year to year. And since the schools in the lab example are the keys, it's really in the kind of the values that you might want to tinker with things.